Hello and a very good afternoon to everyone joining me on this News9 Facebook Live. I'm Pratibha and today I'm here to talk about another ray of hope that has come about. We already know the development that's taking place regarding the vaccine against coronavirus, but there were a few fears among the various challenges that have already come up. There was a challenge as well on whether the vaccine that is currently being developed now would be effective against other types of coronaviruses. As of now, we know 7 types of coronaviruses already, including SARS as well. And there were fears that now, even if a new vaccine is created against COVID-19, there probably could be another amplified version of against which the vaccine will not work. So these were the fears that experts had already put forth. But now, in what has come as a big ray of hope, now the University of Cambridge has said that it is working on a vaccine that can work against the future coronaviruses as well. As we do know, the virus has been existent for a long time, and there were fears that the amplified version of which could be more deadly as well, more lethal as well, which is why there were even further fears and a bigger wait for the vaccine to come about as well. But now, with this news coming in from the University of Cambridge, it is a sigh of relief. It might take perhaps 6 to 12 months as well for the vaccine to be prepared. But once it is done, humanity in itself can heave a sigh of relief, because we then don't have to worry about any other form of coronavirus as well, the kind of fears that we've had until now. Of course, it's a long way to go, but it is a very welcome sign to know that we are going to have a vaccine in the near future. If not within the next few months, after a few more months as well, we are going to have a vaccine against every form of coronavirus, and then we can go back to life as it was and as we knew it. To discuss more on that, joining me live right now is Dr. Sri Vatsa. He is one of the leading specialists, and he's joining me to give us more information on what this means and what's the way forward. Doctor, thank you so much for joining me. I'm sure it's a very busy time for you, for doctors, and thank you so much for taking some time and joining me. Firstly, this is definitely a big relief. It might be a few months away, but it's definitely something we all look forward to. What are your thoughts?
Hi, Pratibha. Thank you for having me on board. So while we are in the midst of this, pandemic, almost not just knee deep, we are neck deep in the midst of it. Now it's quite obvious that vaccine is the only hope to turn this situation around.
True.
And with regards to vaccine development, not just warp speed, we seem to be moving quite fast with regards to the number of vaccines that are coming out. We have almost 150 candidate vaccines. And about 70 of them in active trial, and quite some promising results with the Oxford vaccine, the Moderna vaccine, and many such vaccines. And hopefully we look at, these vaccines in the trials, phase 3, phase 1, are showing some bright signs of inducing antibodies.
Yeah.
And hopefully this immunological response is long lasting, so that the immunity is, quite sustained. And we don't need multiple revaccinations to sustain the immunity.
True.
And it's quite a promising, ideas that are coming out, as well as results from various vaccine trials that are ongoing to help us, curtail this pandemic and inducing herd immunity.
Yeah. Okay, this might of course be a welcome sign. Like you said, it's very encouraging to hear this news as well. But there are challenges as well. It's much easier said than done. As is, we have very scarce information on the current form of coronavirus as well. And even now, experts believe that there could be other types, other forms that could be deadlier or more lethal as well. So with research being so scanty, what are the challenges that the researchers are facing at the moment in developing this vaccine?
See, coronavirus as such is not a new vaccine to humans and mankind, as you already know. We have been earlier infected with the SARS-CoV virus, as well as, the MERS virus, which fall into the same family as coronavirus. The coronavirus is a very large group of RNA viruses. And all RNA viruses has this innate tendency to mutate very rapidly.
Okay.
And hence this is always going to be a challenge that they shift their genetic sequence very quickly. And another important thing with regards to vaccine development is most of these vaccines need to be specific rather than a broad vaccine to cover almost the entire coronavirus gene sequence. Because many a times in the past, because this is not the first time vaccine has been developed against coronavirus, it has been tried with the MERS virus as well as the SARS when the SARS pandemic happened. And it was seen that many a times when the vaccine was developed, there were a lot of associated side effects like antibody-dependent enhancement, which would cause some unnecessary inflammatory process in the person's body, and which would prove to be counterproductive.
Okay.
So researchers are trying to look at specific regions within the genetic sequence. So as you all know, the coronavirus gets its name because of the spikes it has, which looks like a crown. Right. So now we are targeting that S protein in specific.
Okay.
And many researchers in the past have seen that when you target the S protein as such, these kind of antibody-dependent enhancement and immunity that is got as a consequence is not very long-lasting. And hence they are targeting specific regions called S1 region in the genetic sequence. And we are lucky that the genetic sequence for us was available as early as, January. So there is a consortium of epidemic preparedness initiative which was initiated basically to put the entire genetic sequence of the virus onto a platform, which was available for most vaccine developers. And this helped us, figure out which part of the virus we are going to pick and target so that we get a suitable vaccine at the earliest.
Okay, and we are inching, closer towards getting the vaccine, which is quite encouraging. But as far as the University of Cambridge is concerned as well, what the university has said, the word that has been put out is that 3D computer modeling of SARS-CoV-2 would be conducted as well. So how would that be done in development of the vaccine? How is that going to help?
Correct. So what's happening is, many of these proteins, as you know, the SARS-CoV-2 virus has specific receptors it attaches to before it enters the human body. And as already evident, this infection is less common in children because these receptors are less expressed in children. Now, all proteins, you must understand, are 3D structures. And many a times when the virus is interacting with these 3D structures, we must aware of how the virus gets attached to these 3D proteins. And we also must be aware that the various proteins that are expressed by the virus can be, the source of a vaccine development, so that we can counter our vaccines against these particular proteins. So with the genetic sequence already available, we have numerous vaccines against various components of the virus. And we are hoping that, the various vaccine developments that are happening are keeping in mind long-lasting immunity especially. Now, there comes a novel idea by the Cambridge group recently, which has, within correlation with University Hospital Southampton of the NHS Foundation is developing a virus called Diosync-Vax, which is targeted to, basically for the genetic sequence of the entire coronavirus genetic sequence. And hopefully this vaccine will prove promising towards other types of viruses as well, like the old SARS virus or the MERS virus. So hoping that this should be a success. Is too early to say whether this thing is going to be successful. Just like other coronavirus vaccines, the data is too scant and too early on to even be discussing those kind of things now.
Okay. All right. Dr. Srivatsa, many thanks for joining us. Of course, we can hope that the vaccine works. As of now, all hopes are already pinned on the vaccine that is going to work against coronavirus. The fears or a few more challenges that the researchers and experts had been facing was about other forms of coronaviruses. But now with the University of Cambridge saying that they are working on that, it comes as a huge sigh of relief. And, doctors, healthcare workers, people across the world are hoping that the vaccine vaccine actually works. Thank you so much for joining me on this News Run Facebook Live.